Hello, my name is Dr. Phineas Mundawakura. I am a senior lecturer of physics at University of Rwanda College of Education. I am also a facilitator in the CPD Certificate of Educational Mentorship and Coaching of STEM Teachers, a program of URCE and VVOB. In 5E's STEM instruction model, it requires to start a lesson by bringing concept close to the reality so that students can be engaged. Often, phenomena to be illustrated are complex to understand due to many diverse components and interactions. In this case, we use a representation of the concept or of the phenomenon. What are models? Models are simplified representations of a complex reality. This simplification is essential for understanding a phenomenon which is often too complex to understand. For example, scientists use to represent gases by points, as you can see on this figure. And then non-scientists, they use empty space because they don't know what is inside. Using the same representations, scientists can go to represent even liquids and solids simply by, again, using points, but the space between them is going to be reduced. Models are very important because they are useful to summarize phenomena that are not observable because they can be too fast, they can be too slow, they can be too big or too small. In science, we have two types of models. We have mathematical models and conceptual models. Mathematical models, they encode the phenomena into mathematical language. They are represented by equations. Equations-based mathematical models, they describe the relations between different parameters within a system. Here I give you an example of the relationship between the pressure, the volume, and the temperature, the number of moles for a gas. Those parameters for a gas which is evolving, meaning changing its state, they are all related in an equation called equation of state of a gas. We have another type of models, conceptual models. A conceptual model is a way of representing a particular concept or set of concepts that helps the learner to understand or simulate the subject of that model. Often, we use drawings or diagrams to show relationship between factors and the flow of data or process. Here I give you an example of a conceptual model showing how the current is flowing through a simple circuit. Models are having some common characteristics. The first one, they have to be valid. This is typically for mathematical models. An equation describing the mathematical model is valid when the prediction of the parameters it is providing are close to the observations to some extent. If the models or the data given by this model are different far different from the ones which are observed, we have to improve the model or exclude it. The other characteristic is the scope. Usually models have a limited scope in which they have been tested to be valid. In physics, for example, Newton's laws, which are models for mechanics, they are only valid for bodies of low speed. But if you have to treat the motion and the dynamics of a body, which is moving at a high speed, close to the speed of the light, we have to use special relativity equations. And then again, if the mass of the objects are of the size of the atoms, you are not allowed to use Newton's law. You use equations of quantum mechanics. The last characteristic is that models evolve with time. We have an example of a model of an atom which has been changing over the time without meaning that at each time it was wrong, but it was representing the understanding of the people of how atoms are at that time. Models now are useful tools to be used in the 5 E's lesson, but in which step do they have to appear? Models will be used in the explore phase. A teacher can stimulate learners to construct and draw their own models, and then check if what students have been drawing are working, are perfect working compared to how the concept has to work. So learners can also use existing models to answer the key question during the explain phase. My colleague is going to continue to explain another aspect illustrating phenomena using animations and simulations. Thank you.